Hello, students. Jumping into 3-2 homework. So let's see here. Most of these are pretty clear. If you have any trouble with the terms that are used, I did make a very quick video rolling through what was in the textbook. But again, you can also reread parts of that and try the examples. That'd be a really good idea. If you're just relying on videos, things are going to be a struggle. So let's take a look here. We've got, for which of the following sets is it true? Okay, so as you look through the homework questions, we have, which sets is it true that you can do this? This is also, this is a follow-up question from section 2.2 and 2.3. So it's dealing with the sets. Same here. So again, these are set questions. Give an example to show why things must be disjoint. Again, set question. Let's see here. If this is true and this is true, what are the possible values for n of b? And this is a good question to ask. What is possible? Okay, there might be a lot of different things that could be in B, but we're asking how many. Okay, use a number line model. Again, all these things are pretty quick. Uses counting strategy. She says 13, 14, 15, 16, 17. So what two numbers is she adding? Now, again, if you get stuck on any of these, you can jump back into the textbook. That's why we have it. Uses the counting on strategy. So I would go back to the counting on strategy and say, okay, where was that counting on strategy? All right. Oh, got to jump back. This was mental computation. So I'm going back to page 112, 111. This is scratch algorithm. All right. And opposite change algorithm. So let's jump back. Column addition. And come on, come on. Those are all the algorithms. So I got to go back just a little bit more. Looks like I'm over here on page. Oh, where was it? Associative property. Oh, student page. Here we go. So page 101. So counting on is the strategy of addition, counting on. So you'd count on by counting 6, 7, 8. So again, that means you started at 5, and what you're doing is you're counting how many additional numbers are needed to get you to 8. So 6, 7, 8 would be that I'm adding 5 and 3. So if you go back to the homework, oops, I should remember what page it was on, 115? Nope. Negative on that one. 16. Come on, here we go. 7. There we go, 118. So when it says counting on, you can take a look at this and say, okay, so if the first number they say is 13, then they must have been starting at 12. And then how many numbers did they count tells you what two numbers are being added. Use doubles plus 1. So again, you're thinking through how could I solve this if I was dealing with a student. You have a list of sets that you're trying to see if they're closed under addition or not. Okay, so there we go. And I know this is part A, but it's similar questions in part B. Give an example that illustrates a property of addition. So each one of these is a property. It may be more than one property, but most of them I think is just one property. I might give a question on a test that would say, here's 2, right? I'll ask you to, how does the left side equal the right-hand side? And it's going to take at least 2 properties to get there. Okay. So again, they ask you to kind of check some of the techniques they did, breaking up and bridging. Hey, what's wrong with the following addition problem? That's a good one to check. Perform each of the following problems in the indicated base. So you have base 2, base 5 type of additions. Again, think about using the techniques that you just saw for addition. The concept of addition doesn't change just because we change our base. Lattice algorithm, column addition algorithm. Does this work and why? Okay. So this is partial sums as they're kind of going down. And does it work? This is a good one right here. Let me zoom in just a little bit to kind of show what I'm talking about. So here, depending on how you were taught different things, your teacher might have said leave it blank. Your teacher might have said put an X in here because there's nothing that is ever going to go in there, right? If you had 6 10s plus 4 10s, you end up with 10 10s. That means there won't be any 1s. Again, that's perfectly fine. There's nothing wrong with that, other than the fact that X is not a mathematical term. So if you're going to do that, if you're going to be a teacher that wants to use this, I would recommend that you put in 0, because at least when you're doing 0, 4 plus 0, and down here I would have 2 zeros in there, 4 plus 0 does give you 4. When you say 4 plus x, now you've complicated things because we're not talking about algebra. X typically represents an unknown. For students at this level, we don't want nothing to be represented by an X, which then later is going to complicate things. Because if you teach that 4 plus X is equal to 4, the intent, the student is going to start believing that in terms of algebra, that this X is going to always represent a 0. And that's not true. So we'll keep that in mind as you go through. Again, performing additions, trying different algorithms. That's really all this homework is about. That's the biggest part. You'll see it's a fairly long homework set, but each of the questions is significantly shorter than some of the other ones because you'll estimate by rounding, okay? Round to the nearest place value that's in bold. Use trading off front-end estimation, clustering strategy, and would it be a good idea? Like for this one, would this be good to use clustering with, right? And then go back and try those again with front end, grouping to nice numbers and rounding. Okay. Let's see here. Use the range strategy. So again, looking at the highs and the lows, figuring out is between those. Suppose you had a balance of this in your checking. You wrote checks for this, 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 and this. Estimate your balance and tell what you did. Okay. So you had this balance and you wrote checks. Remember, checks are kind of coming out. So to me, this question almost is a little bit of subtraction. However, you could do it as a type of addition if you're counting up, all right? Or using the change algorithm. Let's see here, estimating, magic square. Here we have single digits. This is a great question. 33, like if you're looking to study, 33 is a fantastic one. What's the biggest digit that C could actually stand for, right? What's the greatest digit that A could be as we're doing it? Because again, it has to be a single digit from 1 to 9. So that thinking is fantastic. And here's the addition that we have as we add. And if you take a look, we have quite a bit going on down here to figure out, find the missing digits of each of the following addition problems. So part A, and again, they didn't do a great job separating these, but if you want to, or if you need to, just kind of say, okay, it's just this component right here. So your job is to figure out what goes in this kind of starred space to the 1 plus what gets me to 2. Nudge, nudge, wink, wink, right? You got to love those questions. What, and then they'll put a new star up here. Maybe I'll put a heart up here. What plus 2 gets me to 0? Okay, now again, we're adding only. So when you see a 0, might want to be thinking about some type of regrouping that occurred. Okay. Place the digits in the box to obtain the greatest sum and the least sum. This is a great question for kind of figuring out where do I need to put things. And in the following problems, the sum is correct, but the order's been scrambled. That's fine. Super magic square. Love it. Let's see here, and use scratch addition. So scratch addition in another number base is fantastic. Remember, every time you make a group of 5, in this case, you would scratch and continue on with however many ones are left over. Assessment B looks very, very similar. You'll have the same type of questions. Use the lattice. Draw it. Somebody tried an addition problem here. Is that okay? Will it work? Try it yourself. Use the different methods. Again, here we go. Single digits. Oh, 29. What a question. What a question. Okay, and here's your addition. Now you're doing base 6. What is a possible add-in that can be placed to make this the greatest possible add-in that can be placed to make the correct computation? So you're going to end with 2 and a blank and a blank. What's the biggest number you could put in here? This is really pushing understanding place value. You go too big, you're going to regroup and have 300 something. Well, we don't want that. So how big could I go with these in order to make it still work out? And let's see, I think that's about it. Let's see here. All right, so I'm going to stop this video. I'll do a math connections one separately. All right, well, that wraps it up for this one, homework-wise. Go through, crack on, you got this. Off you go.